All right. So this first one is a, PSAT prep question. Comes from that bank of PSAT prep questions, which hopefully give us a little bit of optimism about the PSAT coming up on in October. So what do we think about number 1? What's our answer going to be? If x is 40, what's the value of x plus 6? C. It's not a trick question. If x is 40, we substitute 40 in here to make it 40 plus 6. This angle's weird. Oops, sorry. All right, number 2 is a little bit more based on what we did yesterday. Several pathways through this. What did you choose to do? Distribute. If you chose to divide both sides by 5, that is absolutely valid, and you can totally do that. So if you distribute, we're going to wind up with 10x plus 40 is negative 30. Then what? Subtract 40 from both sides. And we get that 10x equals what? Negative 70. Yep. Divide both sides by 10 to get x by itself. And we'll have that x equals negative 7. To go back and check, because we do need to check, we'll take our x equals minus 7, and we'll substitute it into our equation here. And you can just do this straight up in the calculator. I'll show you how to do that here, because I know we didn't quite get through that yesterday because I didn't have my calculator pulled up. So, boop. There we go, on my calculator. So to do the check, I'm going to take the side that has my x. I'm going to have my 5 times the parentheses 2. And when we have that 2x, I can either hit times x and use my times symbol, or I can put it in parentheses. Either way. When we have a negative number, make sure we use our negative sign down here at the bottom. The little red one lit up at the bottom. Super important that we use that negative symbol and not this one. The calculator sees them as different things. This means negative number. This is subtraction, the action. So negative numbers are down here. So we have our negative 7 plus 8 and close it. So I just typed everything in. I just substituted in my negative 7 for the x. And it does in fact equal negative 30, which is exactly what we thought it would equal. So we checked it. That counts as a full and complete check. Totally fine. The check is not super intense. The calculator? Yeah. Boop. And it even shows you the key presses here. This set is the buttons that we pushed for our check. Everything before that was from yesterday. So that pink set, 5, parenthesis 2, parenthesis negative 7, parenthesis plus 8, parenthesis enter. Okay, so you can straight up do our checks in the calculator. You do not have to write them down. You have to tell me that you checked. And if we're getting wrong answers with check marks and repeatedly, I know we're not actually checking. So, check it. Questions on either of these two? Okie dokie artichoke. We're going to do one more solving of an equation, and then we're going to head into working with our absolute values again. Because we worked with absolute values with our graphing. Those V-shaped graphs for our absolute value. So we're going to start with solving those. But I wanted to do one where we had a whole lot more letters, because there are some on our homework that are very letter heavy. There's lots of letters. So you don't necessarily have to write down the whole paragraph, the equation, and we need to solve for B. Those are important pieces. We are solving for B. And this is what we're solving. Ooh, that was a weird arrow. There we go. Still weird. I don't like this. There we go. That's a better arrow. This is what we're solving for B. So this is the formula for perimeter on any four-sided shape. Parallelograms, rectangles, squares, any of them. This is the formula for perimeter. So what we're going to do is we're going to solve for B. When it says solve for B, what that means is I want to get this to be a B equals or equals B. That is also fine. It does not matter if it's B equals or equals B. Either one. So my whole goal is going to be to get this guy all by him. No, the stupid fly. He's got to be sitting on the screen. That's how I know he flies. He lands on the screen. Yep. Go there. Why is he chasing the cursor? No, he is the cursor. Come in. Go away. Oh my God. He keeps landing on the screen. Stupid fly. It's so big, it pulls my mouse. It thinks it's the computer. It thinks it's a finger. That's how big that stupid fly is. Obnoxious. I've been in here for 2 weeks now. Stupid fly. All right, so we want this to be a B equals. What do we need to do to get my B by itself here? We don't necessarily want to subtract B on both sides. I don't want to make more B's, and I've got 2 B's over here. So if I have things that are with my B, let's get them to go to the other side. Subtract the A's. So let's subtract, whoa, that's not a pen. Subtract both my A's. So I'm going to subtract this whole chunk. Subtract 2A. And we're looking at our whole equation here, so I'm going to subtract it from both sides. You guys got a question back there? Kenny, do you got a question? I said you got a question? Okay, cool. Just making sure, because I can hear you over here. All right, so when I subtract 2A on this side, those guys are going to cancel out. Can I put these together? Do these have the same variables? No. If they cannot go together, they just sit next to each other. So I'm going to have this as P minus 2A equals, my 2A's canceled out on the right-hand side, and all we're left with is 2B. Still trying to get that B by itself. Because we want it to equals B or be a B equals. It genuinely doesn't matter. So if I have 2B, but I really want to have B, what do I need to do? Divide. Yeah, I've got 2 times B. So to undo that multiplication, we're going to divide by 2. Whatever I do to the right side of my equation, I also have to do to the left. I'm going to show you 2 different ways you can write it. One of them is going to make your brain twitch. One of them is going to feel less gross. So you can divide the whole side by 2. I feel like this one feels gross for a lot of people. Or we can divide every individual term by 2. Anything that's being added or subtracted. This one makes it look super duper. I'm just going to write the other one over here. Super duper ultra fraction. So these 2 ways of writing it mean the exact same thing. They mean the exact same thing. The left side is a little bit easier to simplify. The right side is pretty much done. But this one we can simplify a little bit because I have a 2 over 2 here. So my P over 2 is going to hang out. My minus sign hangs out, but I've got 2 over 2. Those cancel out, so we're just left with our A. And again, I have a 2 over 2, so we have our B. And that happens over here with the B, but everything else in the fraction would stay the same. So if you like the big fraction, your answer would be just RP minus 2A over 2 equals B. I tend to go more this direction, but for some people, seeing 3 fractions in the same thing makes us go, and we get scared. So if this makes you really, really, really uncomfortable, and this is less uncomfortable, go this way. This is totally fine. These two statements are equivalent. They mean the same thing. This one just simplifies further. Okay, so either one of these is fine. So when it says solve for a letter, that's all we're trying to get by itself. So we're going to take anything on either side and get rid of it, just like if it was a number. I just saw that the backside of homework 1 had a whole bunch of very lettery equations, and I wanted to go through one before we moved on to absolute value stuff. Okay, questions on this one? Okay, so that's all it means. When it says solve for like B and it has a whole bunch of letters, they're gonna look kind of gross, and that's normal. You're not gonna get an answer like 4 or 7. It's gonna be a gross, looks like a dang equation thing. But that's how they are. Okay? All right, so what we're going to do now is we're going to talk about solving more things. We're going to talk about absolute values. We worked with those with graphs. That's our V-shaped graphs. And we're going to work with solving absolute values. We've worked with absolute values before, and I'm going to give you a list of steps down here at the bottom for what we do to solve absolute values. And I'm not entirely sure why we have quite so much space here. When we are solving absolute values, we're still trying to get to our x equals. We're going to follow our normal solving steps. But we may wind up with more than one answer. In fact, we will often wind up with more than one answer. If we think about absolute values, I'm just going to give us a little sketch of our parent function. So when we are at -1, +1, 1, or if we're at, we have two different x values that give us a y value of 1. So -1 gives us a y value of 1, and +1 gives us a y value of 1. So if we're solving, we can wind up with two different answers because of this shape. So we're going to look at them, and we're going to practice with them. But we're going to use this set of steps. We are going to isolate. When we isolate our absolute value, that means we're going to get the absolute value bars. I'm just going to write bars. By themselves. When we are working with absolute values as equations, we treat those absolute value bars like parentheses, but if they were jail. You can't distribute in, you can't pull things out. They're in the same set of, same order when we're doing our PEMDAS stuff backwards, but we cannot distribute into absolute value bars. We cannot factor things out of absolute value bars. They are like parentheses, but jail. We're going to split into two different options, and I will show you how to do that. We're going to finish solving, and then it's super duper duper important that we check both answers. So we're going to isolate is our first step to do. Okay, and I will write these steps on every single page that we do with absolute values. We are going to use these in multiple different functions, our isolate and solving. So isolate is going to be a word we use a lot. So isolate means to get it by themselves. So I'm going to give you a couple of not super complicated ones to start. So we're going to start with things like this. And like I said, I'm going to write those words for us up at the top. We're going to start with isolate. Split, solve, and check. So this is like a checklist for us to do. So we're going to start on this side, and our first step is going to be to isolate the absolute value. So we're going to have nothing in, nothing out. These bars are a jail cell, nothing in, nothing out. But I want everybody to go away from the outside. Security lockdown. What do I need to do to get the absolute value bars all by themselves? What is outside my absolute value bars but on the same side of the equal sign? The 2. So this 2 is times my absolute value. So to get rid of it, what do? Divide. We're going to divide by 2. That way this guy cancels out. But whatever we do to the left side of our equation, we do to the right side of our equation. So what we have now is that my absolute value of x equals 6 divided by 2, which is 3. So my absolute value is isolated. It is all by itself. There's nothing else outside my absolute value. Then we're going to do our step that we're calling split. What this means is absolute values have 2 options to give us that output. Yeah, because the absolute value of x, it could be that this piece inside just straight up equals this number. Maybe the absolute value bars aren't doing anything and x actually equals 3. Or maybe these absolute value bars are working. They're doing a thing. What other value is 3 steps from 0? -3. So it's going to be what's inside my absolute value exactly equaling this, or what's inside my absolute value equaling the negative. So that's how we split it. Is there anything else we need to do to solve this? Or is my x already by itself? I was going to say, we've already done our solve, so now we just got to check it. So we're going to check each one of these, and since our calculators don't actually have absolute value buttons, we are going to have to do it by hand. We want to know if 2 times the absolute value of 3 equals 6. What is our absolute value of 3? What is the absolute value of 3? 3. Does 2 times 3 equal 6? So that one checks. We're going to do the same thing for the right one. 2 times the absolute value of -3. And we want to know if that equals 6. What is the absolute value of -3? +3. Once we get to this point, you could absolutely type it in your calculator. But we don't have absolute value bars on the yellow calculators, so we got to make sure we can do some of it by hand. So yeah, that one checks as well. So we did our isolate, we split, we solved, and we checked. So this one is done. Let's do another one. So our first step is to isolate. I need to get my absolute value bars by themselves, no distributing. What can I do to get my absolute value bars by themselves on this side? Divide by 3. I can't distribute the 3 in. Those absolute value bars are like a jail cell. So we are dividing by 3 on both sides, because that'll make this 3 and this 3 cancel out. And all we're going to be left with is our absolute value. Absolute value of x minus 2 equals 4. Do I need to do anything else to get my absolute value by itself? No, my absolute value is all by itself. It doesn't have anything else added or subtracted or multiplied or divided outside of it. So it's all by itself. So now we're ready to split it. We take exactly what's inside here, my x minus 2. So my x minus 2 might exactly equal this number over here. Maybe these absolute value bars aren't doing a dang on thing. So x minus 2 might actually just equal 4. Or my absolute value bars could be working. Ooh. A little loud, but that's okay. Got the point across. Maybe the absolute value bars are working, and my statement inside there, my x minus 2, actually equals the opposite of this piece, or negative 4. So it's really, really important that we keep this argument the same. We keep this the same, and it's that we change what it equals, positive and negative. It is not, this is the most common mistake I see, that this sign changes. It's not going to switch to x plus 2. It's that it equals negative 4 and equals positive 4. So that's how we split that one. Now we're going to need to look at each of one of these and finish our solving. What are we going to do here to get my x by itself? Add 2. Plus 2 plus 2. The minus 2 and the plus 2 cancel out, so we're left with our x equals 6. What are we going to do on this one? Plus 2. And plus 2 on both sides of the equal sign. So what's our other solution here? X equals negative 2. Good. So then we need to substitute those in to check them. We're going to have 3 times our absolute value of 6 minus 2. And we want to know if that equals 12. So we then, when we're simplifying, it looks like our absolute values get treated like parentheses. So we simplify what's in here first. 6 minus 2 gives us 4. So we have 3 times the absolute value of 4. Oop. Absolute value of positive 4 is positive 4. 3 times 4 does indeed equal 12. Oop. So that one checks. On our right-hand one, we've got our 3 times the absolute value of negative 2 minus 2. And we want to know if that equals 12. What is negative 2 minus 2? Negative 4. And the absolute value of negative 4? Positive 4. 3 times positive 4 gives me 12. So that one also checks. So my solutions here are x equals 6 and x equals minus 2. And I'm going to go back and highlight this one. This one was x equals 3 and x equals negative 3. Okay, so now we've done a couple of them. Questions on these ones. Okay. Just a second. Let me say I still see a couple people writing down. All right, we're going to have a bigger one now. We can do this. Our steps are still going to be the same. It's kind of icky looking. But we can do this. Our steps are the same. So I'm going to put them up over here in the corner so they're out of our way. So we're going to do our isolate, split, solve, and check. And this has a lot of stuff happening here. So we're going to start with isolating our absolute value. We're going to get this guy by itself. So we're going to take nothing in, nothing out. This works like a little jail cell. We need this guy by himself. So what can I do to get this guy by himself? Add 9. I want to add 9 to both sides. That'll make this 9 and that 9 cancel out. So we're going to be left with 2 times the absolute value of 5x plus 1 equals 4x plus what? 26. Good. I still need to get my absolute value by itself. So what can I do to get this guy by himself? Super duper close. What is happening between the 2 and the absolute value? What operation is that? Divide by 2. Yeah, this is multiplication. So to undo multiplication, we need to divide. Ooh, and that green is way too dark. It looks just like the black. Hang on a second. Oop, there we go. So we need to divide to undo that multiplication. Whatever I do to the left side, I have to do to the right side. I'm going to do this as the 2 separate fractions because it makes it way easier to simplify. I divide all of the things by 2. Each term. So everything that gets added. So my 2's cancel out on the left. And we're left with just our absolute value of 5x plus 1 equals, and we can simplify the right-hand side. 4x divided by 2 is going to give me 2x. 26 divided by 2, 13. So now we have isolated our absolute value. Whew. Now we split this into our 2 options. This piece is going to stay the same. So my absolute value bars might not be doing anything. It could be that my 5x plus 1 really does equal my 2x plus 13. So maybe my absolute value bars aren't doing a dang on thing. Or maybe my absolute value bars are working their tails off. And this argument, my 5x plus 1, actually equals the opposite of this. So we need the negative of this whole side. Negative of 2x plus 13. So I'm putting the whole chunk into parentheses. So that's how we do our split when we have an expression on each side. We'll put parentheses around it, and we'll go from there. I'm going to zoom it in so we can just look at one at a time because this is a lot of stuff. So I'm just going to look at this purple one first, where my absolute value bars weren't doing any work. I need to solve this, so I want to get this all the way to an x equals. What can I do here to solve this? Be more specific. What do you mean? Yeah, I want to get my x's together. I can't quite do it as a combined like term, so the word's a little bit different, but I totally get what we're saying. Since my equal sign's in the middle, I'm crossing now, which means what do I need to do to my 2x to get it to go this way? Subtract it. We need to subtract 2x from this side and subtract 2x from this side. So be super careful with that, because we should wind up here with 3x plus 1 equals 13. What's my next step going to be? Oh, this is the wrong room. Huh? Oh. So what's our next step going to be to get my x by itself? Subtract 1. So let's subtract 1 here. It's going to give me that 3x equals 12, because those guys cancel out. Last step on this piece, divide by 3. To get my x equals 4. Whew. We get to do it all again on the right side. Questions on what we did over here? Because we're going to do the very similar process over here. We got to do the whole solving part again. So what's our first step going to be looking at this side? Yeah, let's distribute this minus sign through, because it's ew right here. So this side is going to be our 5x plus 1. And then we're going to have minus 2x minus 13. So it changes all of our signs, but other than that, it doesn't do much. So now, again, I'm going to try and get my x's on one side and my numbers on the other. So what do I need to do to get my x's to one side? Add the 2x. This time we're adding it. So we're going to now have 7x plus 1 equals negative 13. What am I going to do next? I can minus 1 from both sides. That's going to give me that 7x equals negative 14. One more step here. Divide by 7. Good. So what does our x equal? Negative 2. So sometimes these are going to have a lot of pieces. Because we also should go and check this. We can do this in a couple of pieces when we check. For our 4, we're going to set up 2 equations in our calculator. Oop, not that. So we can start with our right-hand side of our equation, where we had our 4 times our x of 4 plus 17. So we want our left side to equal 33. And then we have our 2 times 5 times 4 plus 1. will that be a negative value inside the parentheses there? Or will that be positive? Positive. So this is the one where my absolute value bars aren't doing any work. So we can just put it in like this. And then we had our minus 9 on this side. This one also equals 33. So we can do a lot of this in the calculator. We just have to be super duper careful with this statement right here. Because if this statement's going to be negative, we're going to have to do an extra step. So my 4 checked. Let's do our negative 2, and then that'll probably be our last one for today. So again, I'm going to have to do the right side, where we're going to do our 4 times 2. Oh, sorry, negative 2, right? Negative 2. 4 times negative 2 plus 17. So our whole statement should equal 9 on the left-hand side. Then I'm going to look at just my absolute value piece. That 5 times negative 2 plus 1. Is this piece going to be positive or negative? What do we think? 5 times negative 2 plus 1. Got a negative 9 here. So when we're putting this into our left-hand side equation, this is the absolute value bar. So when we're putting it in, we can do this in 2 separate pieces now. 2 times, oh, hang on, I think somewhere I need to write. 2 times, but instead of putting in that negative 9, that's inside the absolute value, so that's going to be positive 9. So if my inside of the absolute value is negative, we're going to have to do this in 2 steps. And then back to my original equation, we should have our minus 9 here. Since my top piece matches the bottom piece here, this one also does check. That's not sure about. So it's a little awkward when we have too many X's on here to check things, but it is important that we do. We did check this one as well. Okay, so they're a little weird and they're a little bit awkward and a little bit gross, but we can do it. Okay. Questions on these? They're a little gross. They just take a little extra practice, but we can do this. Okay. So yesterday's homework was all about solving. I do also have a homework for us for our absolute values, which I want to find it. I'm going to put it up on my little tray table for you guys to pick up. We're going to work more with absolute values tomorrow. So this, okay, thank you. I was going to say, so if you want to just wait and pick it up until tomorrow, that's totally fine. Just because I know I gave you one yesterday. We're going to work more with absolute values tomorrow. So we're going to practice with these and we're going to look at these kinds of problems. But I want to give it to you if you want to start working on it. If you finish the solving homework, that is a great time to start it. But also, I just gave you one yesterday, and I know sometimes that's overwhelming. So, take care of yourself. Homework 1 is due tomorrow. Homework 2 is due on Monday. Okay? We got there before the bell for the announcement.